Hey, Algebra 2. This is your day 2 review. So I'm going to be going over the problems that you're going to be doing on Friday. Again, remember you can use a calculator for this section. And that's about it. So let's get started. Alright, so first this problem says a colony of bacteria with an initial population of 10,000 decays over time, t hours at a rate of 12% per hour. What will the population be after 21 hours? Well, first we need to know what equations are we even going to use in this case. Okay, there's two to choose from. We have A equals P times 1 plus or minus R raised to the T. And then we have A equals P times 1 plus R over N raised to the N times T. So the case when you're going to actually use the second equation is when you're going to have compounded interest problems, such as the one below where you see this keyword compounded or compounded quarterly. If you see compounded in your sentence, then you want to use the second equation. Otherwise, just use the first. Okay, so let's go ahead and plug in our values. So first, the P is our initial or starting value, and it says we started with an initial population of 10,000. So there's our first value we want to plug in. A equals 10,000. And then we want to do 1 plus or minus. We have to decide. Well, if we look at the sentence here, it says decays over time. If something decays, that means it's decreasing over time. So we're going to use minus. And then the next one is R, which stands for our rate. In this our case, our rate is 12% per hour. And remember, with percent, we want to change that to a decimal, and we do that by moving, the decimal 2 places, and this becomes 0.12. So 1 minus 0.12 raised to t, which is our time, and that comes from the question itself. What will the population be after 21 hours? So we put in our 21 here. Okay? So what you want to do is go ahead and plug this into your calculator. So let's pull up in our calculator. For the test, you'll be able to use your TIs. Let's go ahead and I'll be using the web calculator. Okay, so let's go ahead and plug it in. 10,000 parentheses 1 minus 0.12 parentheses raised to the power of 21. So we get a value of 682.5525 blah 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 blah. Well, we're talking about bacteria, something that's actually living. And living things don't come in pieces. They come in wholes, right? So this is 682 bacteria. So we don't want to round to like the nearest 10,000th or the nearest 100th. We actually want to round to the nearest whole number. Okay? So we want to round this 2 by looking at the 5, the number next to it, and say if that's 5 or bigger, it will round it up. And yes, it does. So it'll be 683. So we'll end up with 683 bacteria after 21 hours. Okay? Now the next one. Now again, this is the problem where we're going to have compounded interest, because it says we start with or invest $1,295 into the neighborhood bank because they said that they'd have the best interest rate, there's the key word, 2.8%, and it's going to be compounded quarterly. How much will I have after 14 years? Okay, so we're going to use our compounded interest equation. And again, we're talking about an increase because we want that it's going to increase because we have interest that we gain every year, or in this case, quarterly. So we're going to use plus. So A equals the initial amount, 1295, times 1 plus, because we're gaining, the rate, which is 2.8, and remember we move that 2 decimal places to the left, so it becomes 0.028 all over, all over 4, because we're talking about quarterly, which means we're dividing a year up into 4 parts. And now our exponent will be n, which is 4, times t, which is 14. So let's go ahead and use our calculator. And it'll be 1295 times 1 plus 0.028 divided by 4 raised to the power of, you want to put parentheses around your exponent, 4 times 14. Okay, so remember we're talking about money. Oops. We're talking about money, so we want to round this to the nearest cent. The cents are 2 decimal places after the decimal. So it would be $1,913.90 because this 3 is not going to change to 0. So A is equal to 1,000, it's money, $1,913.90. And so this is the amount that you'll have after 14 years invested in a neighborhood bank. You'll make about, let's see, a little over $600. Okay, now the bank down the street said if I invest the same amount into an account, they'll do continuous compound interest. Now, we're not going to use continuous because that's a different type of interest and we didn't learn that one. Okay, so we're going to do monthly. And monthly means we have 12 months in a year, so our n is equal to 12 in this case. And our interest rate is going to be 3.1%. What would be the balance of the investment after 17 years? So A is equal to, again, $12.95 times 1 plus, because we're gaining money, and remember this rate is going to move 2 decimal places to the left, so it would be 0.031, over n, which in this case is 12, because there's 12 months in 1 year, and then the exponent will be n, which is 12, times 17 years, which is our time. So we'll go ahead and put that in our calculator. Okay, so now we'll do 10,000. Oops, sorry, not 10,000. 1295 times 1 plus 0.031 divided by 12 raised to the power of, in parentheses, 12 times 17. And our value is going to be $2,192. And looking at the cents, we look at the second decimal place, look to the right, we have a 6. That 6 will change the 3 to a 4. So $2,192.04. $2,192.04. Okay. That will actually give us a greater return if it was compounded monthly as opposed to quarterly over 17 years. Okay, now the next one, we're going to simplify these expressions. Now the goal is that we want to end up with an actual value, like a 1 or a 2 or a 3, a 7 or an 8. So first, if you have 3 logs, we could work on these all together at once. Only if the bases are the same. But you'll notice that this base is 1/5, this base is 1/5, but this base is 4. So they're all different. So we can remember we can only combine the ones that have the same base. So let's start on the left. So these have the same base. They're separated by a plus, so we can use our product property and multiply those a's. Now off to the side here, I'll multiply that 25 times 1 over 20. 1 over 125. We'll multiply that. Let's make this a fraction. And we multiply the numerators. So that's going to be 25 over 125. But we can also simplify that. Divide both of them by 125. And we'll get 1/5. Okay. So we'll have 1/5 here. Plus the log of base 4 of 1. So now we can't really use our properties to combine these two logs because we have different bases. But what we can do is simplify each of them one by one. So let's go ahead and take this log base 1/5 of 1/5 and simplify that alone. So log base 1/5 of 1/5. Well, I know that's equal to some number, x we'll call it, and we'll change that to exponent form. So now that's equal to a, which is 1/5, and this is 1/5, this is 1/5, and I know that 1/5 here is raised to the power of 1 because it's just 1/5 itself. It's not an exponent or it's not squared or anything like that. So that means this has to be the same. So then that first number is equal to 1. And then let's evaluate or simplify the second one. Log base 4 of 1 can also be written as 4 to the some number x equals 1. Well, the only way that 4 can equal 1 is if the exponent is equal to 0. So there's our number, 1 plus 0 is equal to 1. So our answer is 1. Okay, now the next one down here, the C, cross that out. We're just going to focus on B. Okay, so this one, remember if there's no base, it's equal to 10. And we'll say this is equal to some number x. So we'll rewrite this as 10 to the x equals 0.0001 squared. So we need to figure out what do we have to raise this power of 10 to equal this decimal number here. Okay, so if we look at, let's take a look over here. If we have 10 to the negative 1, well, that's equal to 1/10. 1/10 is also the same as 0.1. 10 to the negative 2 is equal to 1 over 100, which is equal to 0.01. So we have to figure out how many decimal places is this, or how much would we have to raise this to in order to match this. Okay, well, let's try 10 to the negative 3 is 1 over 1,000, and that would be add a 0, 0.001, but we only need one more 0. So if I do 10 to the negative 4, that will give me 0.0001. And remember, it's that number squared, so keep the 2 outside, and then this will be 10 to the negative 4. Then just multiply the exponents, and we'll have 10 to the negative 4 times 2, which is negative 8. So then our answer is x equals negative 8. Or, in other words, the value of this expression is negative 8. Okay, now solving equations. Okay, your bread and butter for Friday. Okay, remember you have two options here. Option 1, make the bases the same. Okay, option 2, I'll write that over here. Option 1, change the bases. Option 2, log both sides. Okay, so let's keep that in mind as we go through this. Okay, so the 8 and the 16, we want it to be the same base, so we got to think of what number could we change them to so that they have the same base. Well, I know that if I raise the power of 2 to some number, I could get these to be the same base. So now 8 is 2 to the 3, and the exponent is 3x minus 1 is equal to 16 is 2 to the 4. Oops, sorry. And that's raised to 2x. So now our bases are the same, so let's multiply the exponents. And here we want to distribute this 3, so 3 times 3x is 9x. 3 times negative 1 is negative 3. And then same thing over here, multiply the exponents. 4 times 2x is 8x. Now since our bases are the same, we can set them equal to each other. So we'll do 9x minus 3 equals 8x. And then just solve this like you would any other equation. I want my variables to be isolated, to be by themselves, and I want my constants or my numbers to be on the other side. So what I'm going to do is subtract 8 from this side and add 3 to this side. That will take away this 3 from this side and take away this 8x from this side. But again, whatever we do to one side, we have to do to the other. So minus 8x here and plus 3 here. And now I end up with x equals 3. Problem solved. Okay, so now B. Again, we want to try to get the bases the same if we can. So let's see. 2 to the, should we do 4? Should we do 2? Let's see. 2 to the 4th? Let's try 2. Alright, let's see if we can do 2. So we can use your calculator. And let's do 2. Let's raise 2 to the power of, I don't know, 7? No, let's do a little more than that, maybe 10. No, that's too much. So let's do 8. 256, that's too much. Let's do 9. 512, that's too big. So we can't use the base of 2, because that's too small and too big. So how about 4? Let's try 4. Okay, now 4 raised to the power of, let's say, 5. It's too much. 4 raised to the power of 4 is equal to 256. So neither way is going to work. So that means that we can't make these bases the same. Okay? Because I know I can't do a base of 3, because that won't work for the 4. Really, the only options are 2 and 4. So that if I can't use either one of those, then I'm going to have to use a different method. I'm going to have to use log. So let's log both sides. This is option 2. Log of 4 of x to the x minus 2, and then log of 400. And now let's use those properties of logs. I know that if I have an exponent here, I can move it to the front. And this becomes x minus 2 times the log of 4 equals a log of 400. And remember that my goal in any equation is to isolate x by itself. So let's see if we can get rid of this log of 4 by dividing it. Let's divide it by both sides. Okay, so that cancels out. And before I start figuring out what the actual value is, let's do all we can so that we can just enter the entire calculation on the calculator. So this is x minus 2 equals log of 400. So I'm just going to rewrite the log before I actually figure out what the value is. And the last step is to get x by itself is I want to add 2 to this side. And so I'll add it to both sides. So to get my final value, it's going to be log of 400 divided by log of 4 plus 2. So let's go ahead and do that on our calculator. So now log of 400, remember put a parenthesis after that, divided by log of 4. Okay, let's figure out what that is. And then remember, the last step was adding 2. So then we're going to do plus 2. Okay, so then our answer is 6.3219. Now let's go ahead and round to the nearest 10,000. And 10,000 is 4 decimal places after the decimal. So 1, 2, 3, 4 is a 9, and that 2 is not going to change the 9, so it'll just be 6.3219. 6.3219. Okay. Now on this one, remember if I, just like the last one, I can take the log of both sides. But then I can also go back in the other direction. Let's say I started with this log of 4 to the x minus 2 equals log of 400. I could go back to the original problem, 4 to the x minus 2 equals 400. In other words, if these logs are the same, they're both the same base, I can cancel out the logs. So with that in mind, these logs are the same here and here. They both have the same base, so I can actually just cancel those out. And now it becomes an easy equation to solve. 5x plus 2 equals 3x equals 3 minus x. Okay, so we'll add x to this side and this side. Oops. Plus x. And then subtract 2 from this side and this side, and that cancels out. 5x plus x is 6x, and then 3 minus 2 is 1. Divide both sides by 6, and x equals 1 over 6. And one thing I didn't mention is that you want to make sure that you check your answers. As you can see, it says check for extraneous solutions. Okay, that doesn't mean you have to actually plug in this and then evaluate the entire thing on paper. All I'm expecting you to do is show me that you're actually checking it. And what you can do is, let's say for this first one, the answer was 3. So plug in 3 where the x is in the original equation. And so it's 3 times 3 minus 1 equals 16 to the 2 times 3. And you could simplify that if you want. Then that's going to be 3 times 3, which is 9, minus 1 is going to be 8. And this is going to be 16 to the 6th, because 2 times 3. And then what you can do is just go on your calculator and just double check to make sure that's correct. Oops. So now we would do 8 to the 8. Well, that's equal to this big number, 16,777,216. Now let's make sure that the other value, which was 16 to the 6th, let's make sure that's equal. 16 raised to the 6th, and we get the same value, 16 million, blah, blah, blah. Okay? And then you can just say, hey, I checked it. See? I get plus 1 point just for checking it. All right? And we can do the same thing with all these other values. Now, when you have to round your value here, it's not going to come out to exactly right when you plug it back here. But it should get pretty darn close. So if I plug in the 6.3219 minus 2, that should equal 400. Okay, so 4 raised to the parentheses 6.3219 minus 2. That should be pretty close to 400. Now, as you can see, it's not exactly 400, but it's very close. And if you round it to the nearest whole number, that will actually equal 400. Okay, so that is right. So we're good there. And then you want to go ahead and do the same thing here. Log base 7 of 5 times 1/6 plus 2. And make sure that equals log base 7 of 3 minus 1/6. So you want to go ahead and enter this in the calculator. Now, in my calculator, I can't do log base 7. On the TIs that we have in class, you can do log base 7. But as long as you enter the same base when you check your answer, it'll still work. So if I decided to make, instead of use 7, if I use 10, and I use 10 over here, it'll still work. Okay, so I'm just going to go ahead and use regular log on our online calculator. So let's go to our online calculator. If I do log of 5 times 1/6, and I'll put that in parentheses, and that's plus 2. Put all of that in parentheses. Let's figure out what that's equal to. Well, it gives us 0.45229 and something something. So let's double check the other side of our equation. So it's log and 3 minus 1/6. So let's do log 3 minus 1 divided by 6. That should give us the same thing, and it does. 0.45229 and so on. Okay, so that does work. All right, now I'll move on to this next one. Now here we have logs on the left, but on the other side we do not. So let's go ahead and combine this left side, because we do have a plus between the two logs, and they have the same base. They're both 10. So if it's a plus, remember that is going to be the product property, so we can multiply the x times x minus 21. And then this is going to become x times x, if we distribute it, x squared, and then x times negative 21 is minus 21x equals 2. So now what we want to do is use our property that says log of base b of a is equal to e. Okay, so in this case our base is 10. So if we do 10 to the e, which is our 2, then that equals x squared minus 21x. And so now we have x squared on this side, and we have numbers over here. So we want to solve this like a quadratic. Okay, so we want everything on the right side and set it equal to 0. Okay, so I know that this 10 squared is 100. And I want everything on the right side, because I want x squared to be positive. So let's subtract 100, and we'll do it from this side as well. And now we have 0 equals x squared minus 21x minus 100. Now what we need to do is factor this to figure out what are my solutions. Okay, so we could use our x to factor, and remember the top number will be the first times the last, so it'll be 1 times negative 100, and then negative 21 on the bottom. And let's see, what number is multiplied to 100? 10 and 10, 20 and 5. See, 10 and 10 won't make 21. 20 minus 5, or 20 plus 5, no, that won't make 21. So let's see, 4 times 25. Well, I could probably make 21 with 25 and 4. Okay, and it has to be negative, so that means the bigger number is going to be negative. 25 plus 4 is negative 21. And negative 25 times 4 is 100. So now we have x minus 25 and x plus 4 equals 0. Okay, so now we know x is a liar, so if this is negative 25, our answer will be 25, and if this is plus 4, then we know our answer will be negative 4. Okay, but again, we need to check our answers to make sure we don't have any extraneous solutions. Okay, and especially if you end up with two solutions, more than likely one of these is not going to work. So you got to test them both. Okay, so we get the log of x, or the log of 25, plus log of 25 minus 21. So that will be 4. Let's make sure that equals 2. Okay, so now the log of 25 plus log of 4 needs to equal 2, and it does. Okay. All right, so that one's good to go. And now we need to check the negative 4. So negative 4 plus log of negative 4 minus 21. Well, that's going to be negative 25. And we need to make sure that equals 2. Now, before I even go any further, one thing you need to know is that you cannot take a log of a negative number. There is no value where we can plug in a negative number. Kind of like a radical, or a square root, you can't plug in a negative number. It's the same thing with log. Okay, and let me show you what happens if I try to enter that on a calculator. Log of negative 4, and then it says error, invalid, negative argument. It doesn't like it because it can't happen. And some of you would say, oh, well, can't we just combine the negative 4 and then 25, and then that becomes positive 100? But it has to work for the original equation. Okay? Yes, these two would make positive 100. You could take the log of 100, but that wouldn't work. Okay? Because these are negative. So that does not work. So the only answer is x is equal to 25. Okay? So if you plug a number in and you get an error, then that number is not going to work. Okay. All right, so now this next one. So I see that I have a number that has x here, and then I have two constants here. Well, I want to get x by itself, so let's start by moving things around so we can start isolating x. Well, I know if I add 5 here, I can get rid of that 5 from that side. So we have 25 plus 5 is 30. And first option we want to look at is, can we make the bases the same? And I can't raise 5 to any number to equal 30, so we'll have to take log of both sides. 5 to the 4x minus 1, and then log of 30. Okay. Oops. Move this over to the right a little bit. And then we have an exponent here, so we can move that to the front. So now 4x minus 1 times log of 5 equals log of 30. And we're going to divide both sides by log of 5 to again try to isolate x. And so now we have 4x minus 1 on this side, and log of 30 divided by log of 5. And then let's add 1 to both sides. Okay. So we have 4x equals log of 30 divided by log of 5 plus 1. And then the last thing we need to do is get rid of this 4, and I can either divide by 4 or multiply both sides by 1/4. You're doing the same thing. Whether I divide by 4 or multiply both sides by 1/4, I'm getting the same result. So those cancel out. So now x is going to be equal to this side evaluated. Okay, so let's go ahead and do that. So we're going to have log of 30 divided by 5, or log divided by log of 5. Okay, and we're going to add 1. So actually put parentheses around that, around all of that, and then add 1. Okay, and you can see what we're doing up here at the top. And I'm going to put parentheses around that, because then I'm going to multiply everything times 1/4. Times 1/4. Okay, so as you can see, I have the same thing that I have on the other page. I have here log of 30 divided by 5 plus 1 times 1/4, which is doing the same thing as dividing by 4. And my value is going to be 0.7783. Remember, we want to round to the nearest 10,000, so that's 4 decimal places. 1, 2, 3, 4. This 2 is not going to change the 3, so there will remain 3. So we'll have 0.7783. And again, we want to just go ahead and double check our answer. Just plug it back into the original. Nice thing about the TIs is that you can just redo or copy what you just did and just plug in that value. Okay, so now this is going to be 5 raised to point, let's see, what was it again? 5 raised to 4 times 0.7783, and then minus 1, okay, and then all of that minus 5. And that should be pretty close to 25. That's what we want, this 25 here. So that is pretty close. We have 24.996. So that is correct. All right. Okay, so 2 more of these solving equations. Okay, this one, we're actually going to skip that because that involves the letter E, which is actually called Euler's number, but we didn't learn that, so we'll skip that. Okay, so we'll do this one as our last one. Okay, so here I have log on one side, I have a number on the other. So I'm thinking let's use our property that says we can rewrite this as an exponential. Let's try that. Okay, 3 to the 36. Whoa, that's a big number. Equals x to the 4th. Well, those are pretty big numbers. Maybe we should choose something else, because I don't know if I want to work with an exponent that's 36. So let's think about our other properties we can use. Well, I know this exponent, if I bring it to the front, well, now it's 4 times log base 3 of x. Okay, well, it's starting to look a little better, sort of. Well, I know this 4 over here and this 36. Well, I could divide by 4 on this side and this side. Because remember, I want to isolate x, right? So I could probably get rid of this 4 by dividing it. And now I have log base 3 of x equals 9. Okay, this is starting to look more manageable. I don't have that scary exponent up there anymore. So now let's change it. So now 3 to the 9 equals x. Oh, there we go. And then let's figure out what 3 to the 9 is. With our trusty old calculator, 3 raised to the power of 9 equals 19,683. 19,683. So you just kind of have to try different methods, see which one's going to work for you. Okay? That was our last one for solving. Okay, now the last one, describe the transformation based on the parent function. Okay, so here's our parent function, and we want to describe the transformation. Okay, so we started with this. Let's look at one thing at a time. Let's look at what we plugged in here. So we originally had x, but now we have x plus 1. Remember, x is a liar, and when we change what we plug in, that moves it left or right. And if it's plus 1, well, that means it moved to the left 1. Okay, so it moved to the left 1. And then let's look at the next number to the right, which is the 6, and we're adding 6 to the outside. And remember, if we add to the or subtract to the outside, we're moving up and down. And in this case, we're adding, so we're going up 6. And then in the front of the equation, we have a negative. Negatives always cause reflections across the x-axis. Reflect x-axis. And then the last one is this 1 over 3. Well, I know a number in front of any function, if I multiply it, causes a vertical compression or stretch. And this one is less than 1, so this will cause a compression. But don't worry, on the test we won't have any vertical compressions or anything like that. We're just going to have to worry about left and right, up and down, and reflections. Okay? That is it for your review. Any more questions? Send me a message on Remind. See me before class. It's 3:40 right now, and I haven't had anyone but Chris Ramos in here. So I take it I won't be seeing anybody after school. But if you want to show up before school, before class, at lunch, you are welcome to come. Otherwise, I'll see you all tomorrow.